We built a tiny world for 1,000 ants, a crazy obstacle course, with a simple promise: either they fail, or they invent a new way to win. What you're about to see isn't a trick. It's a close look at how these tiny creatures solve huge problems together. From digging tunnels by hand to crossing fragile tightropes and navigating sticky lava, you'll witness incredible cooperation, improvisation, and at least one hero you'd never expect. The box clicks open, and 1,000 ants spill into their new world. For us, it's an experiment. For them, it's a strange new land. Grains of sand are like boulders, tiny sticks are fallen trees, and a piece of fruit could feed a whole dynasty. Their antennae sweep the air like tiny radars, tasting the chemicals and mapping the space. Instantly, they get to work. There's no single commander, no blueprint. They just follow the simple, ancient rules that make ants the masters of collective intelligence. They don't plan for the future. They respond to the now. And right now, there's a pile of sand with something delicious buried underneath. Within an hour, the center of the arena is a buzzing construction site. Workers vanish into the sand and reappear carrying single grains on their backs, depositing them in a neat pile. If you watch long enough, you start to see patterns. There are traffic lanes for ants hauling away debris, scouts exploring ahead of the diggers, and a few bolder ants leading the charge toward the buried reward. This is exactly how they build their nests in the wild, thousands of small actions adding up to incredible architecture. The speed is surprising. What looks like chaos is actually super efficient. The algorithm is simple: pick up, carry out, drop, and return. But this course is just getting started. The next challenge is a tightrope stretched over a pit with slippery walls. It's a test of balance and risk. The ants reach the edge, hesitate, and then do what ants do when they're unsure. They swarm. At first, they avoid the string, sticking to the safe edges. But a few motivated workers, guided by scent and hunger, step out onto the thin line. Ants have a special relationship with surfaces. Their adhesive footpads and tiny claws let them grip things that seem impossible to us, and they communicate. A single worker who finds a way across leaves a pheromone trail, turning the path into a tiny highway. In one amazing trial, a single determined worker grabbed a crumb far bigger than itself, balanced along the string, and walked all the way back with the prize. This isn't movie magic. It's a feat born from persistence, friction, and the tiny mechanical miracles of ant anatomy. When the colony needed a bridge, one ant became an explorer, and, in doing so, rewrote the map for hundreds of others. Sometimes, the cleverest solutions are accidental. We sealed a paper vault with glue, making it impossible to get into. The ants tested it and gave up. But then we brushed a little sugar water on the paper. Suddenly, the vault wasn't just a barrier. It was food. The softened paper started to droop, creating a tiny hole. Time and again, it's an individual ant, not a team of masterminds, that clears the path for the colony. That one ant's success becomes the colony's success. This is the moral of the story for social insects. Local initiative, backed by collective reinforcement. We gave them a few tools: dirt, string, wood chips, to see if they would use them. It's a miniature civil engineering project, but the ants don't know they're being clever. For them, it's just instinct. Fill gaps, smooth paths for heavy loads, and keep the scent trails going. Sometimes, a single ant made it across the sticky zone alone. Other times, the collective built a bridge, and hundreds crossed together. Either way, the colony solved the problem. Not because any one ant was a genius, but because many ants were reliably, incredibly persistent. Watching these tiny bodies navigate our crazy contraptions really makes you rethink what intelligence is. There's no single smart ant in the way we think of individual genius. Duplicating that tiny act thousands of times builds architecture and creates intelligent behavior. This is the lesson of the tightrope walker, the vault breaker, and the ant that sprinted across the sticky tape. Local explorations are amplified by social feedback. Of course, there are limits. Observing animal behavior must always be about curiosity with compassion, never cruelty. These experiments show both the amazing agility of ant colonies and the fragility of each individual worker. Beyond the spectacle, these exercises teach us about ecology and design. Engineers and roboticists study ants to design swarms of robots that can explore disaster zones, form temporary bridges, or move materials together. Behavioral ecologists study the tiny details, how pheromone rules create traffic flow, how a division of labor makes digging more efficient, and how simple choices lead to exploring new territory versus exploiting known resources. Ants are a living laboratory for distributed algorithms. Our 1,000-worker course is tiny compared to a wild colony, but it mirrors the natural challenges they face: floods, fallen trees, and hidden food sources. The same behaviors that solve our little puzzles scale up to solve massive problems in the wild. At the end of the day, there's a small ceremony. The successful ants haul their food back to a new, upgraded nest. Those individual heroes, the one who crossed the rope with a crumb, the one who slipped into the vault, the one who sprinted across the sticky tape, they all fade back into the crowd of workers. In a colony of hundreds of thousands, individual fame means nothing. What remains is a quiet appreciation for how 1,000 small bodies, each acting on just a few simple cues, can build cities, overcome engineered traps, and solve problems that, from our perspective, look like feats of pure genius. The experiment was never about winning a contest. It was about learning how very small things, acting together, can literally change the shape of their world.